All right, we're going to talk about the area of quadrilaterals, and we're going to use a technique called shearing to find the area, um, so that it's almost like proving that the area of a parallelogram formula works. Or if you don't know the base and heights, like on this one, it's hard to tell because it's all shifted. Here, base and height is pretty easy to tell, but that's not always going to be the case. How you can find the area on a grid anyway. Okay, so shearing, essentially how this is going to work is I need to pick a side that I'm going to shift things on. So if I'm going to shift this point, and I could have picked down here or up here, but I want to try to straighten this out so it's not at a diagonal anymore. So if I shift this one to the left, so like if this was A and now we have A prime, and this was B, I have to shift it the same amount. So this would be B prime. And now I have a new rectangle here. Let me make it a different color, where I'm going to connect these four. And since I moved them both the same distance, they're going to have the same area. So here I have 1, 2, 3, 4 by 2 is 8 square units. Okay? This one we're going to do the same thing, but we'll have to do it in 2 steps. The reason we could do this one is in 1 step is because I already had 2 sides that were horizontal. They weren't at a diagonal. So here, let's say I'm going to move along this side first, and I could have picked this one instead, and I could have done a different direction first also. But let's say I want to move this down so that it's on the same plane as this point. So then if this was A, now we have A prime. If this was B, I have to move it the same distance. So it'd be down to here for B prime. So now I have these points in a row and these points in a row, but I need to get them stacked on top of each other. So let's do that part next. So along, I'll use a different color again. Let's say along this side, we're going to shift everything over 1. So if we call this one C, then C prime would be here. And then we're going to shift this one over 1. So we'll call that B double prime. Every time you move it, you can add another tick mark. So now, if we connect our final shape, I'll have a rectangle. And this would be 2 by 3.5, which would be 7 square units. Okay, and it might be helpful if you don't have different colors at your disposal to shade in the final figure so you can keep track of what happened there. Use dissection to determine the area of given shapes. So this means like I'm going to take this piece, I'm going to cut it off, I'm going to put that same piece, the same piece over here. So now this is my new shape, my new rectangle, and it's 4 by 2, which will give you 8 square units. Okay, so again, these are kind of proving that these parallelograms are base times height. Like this was 4 by 2, 4 by 2. And this one, it was hard to find your base and your height just by looking at it. So we had to use shearing to figure out the dimensions. Find the area of the figure. So I'm going to use, since this is a composite shape, I'm going to use dissection and do it in 3 pieces and then add it together. So in this case, I have 6, 3, and that would make this 1. Because the whole thing is 10, that's 6, this is 3, so this little piece must be 1. And we also know that this piece is 3, so 3 times 1 is 3 centimeters squared. Here, 10 times 3 makes each of these 30 centimeters squared. So if I add them together, I have 63 square centimeters. For a parallelogram, it's base times height. So you have 8 times 2.5 should be 20 square centimeters. For a square, it's your side squared. So if I have 3 root 2 and I square it, that would be 9 times 2, or 18 square centimeters. Population density. This is find the area and use the given population of decimites for each figure to determine population density. So down here, I'm just going to add that population density is the number of people, or whatever your population is, over the area. Okay, that's the order it goes in. So in this case, it'd be mites over the area. But it could be any population. So here I have a 30, 60, 90 rectangle, which helps me because I know that they have the relationship of x, x root 3, and 2x. So this is my hypotenuse, so that's my 2x, which makes my shortest side 7, and this one 7 root 3. So my area is 7 times 7 would be 49 root 3 square centimeters. And then I have to take 340 divided by that to find my population density. So this is roughly 4. It's a little bit off, but 4 mites per square centimeter. Okay, that'd be your label. Okay, mites on top, square centimeters on bottom. Here, I need to figure out this length, so I can use Pythagorean theorem to find that. So I'm going to divide this here. 10 squared plus b squared equals 26 squared. So 100, 676. And square root that is 24. Okay, so my area would be 240 square centimeters because I have to take base times height. And then I'll take 300 divided by that to find my population density. So 1.25 mites per square centimeter. Okay, here I need to find this height to get the area. And this is a 45, 45, 90 triangle, so we know that they have the x root 2 relationship. So if this is 5 root 2, that means both of these are 5. Okay. And then it's a little bit hard to tell, but I believe 11 is this whole side, so I don't want to add these together. I'm just going to take 11 times 5, which makes my area 55 square centimeters. And then to find my density, I'm going to take 165 divided by 55, which I believe is 3 mites per square centimeter. All right, your assignment for today is pages 15 through 17. And I'm going to go ahead and post the key since I'm out of the building today. So do the best you can to get these completed, and I'll be back on Monday to answer your questions.